unfortunately choose not to join us live, but we know live is way better.
Way better.
So I am recording, so that way we can get that up. And if you miss anything today, you can obviously go back and do it live, or go back and do it on the recording. We are going to move quickly through definitions today. It's just the nature of the beast. I sent them out yesterday, so you can get them that way, or when the video goes up, you can pause the video and write the definitions down there. It's just, we aren't going to just stop and use our time for that. The sooner we get through it, the sooner we get you guys on to whatever else your day holds for you. So hopefully maybe a little bit more math practice. So are we ready, Miss Rondeau?
I believe, yes. Sorry, I was just looking at the names and counting. Miss Rondeau's class bumped it up a little bit today, although your class is still beating us, I think. But we're not 2 to 1. We're closer to even. Yay, good job, Rondeau.
50-50. I want to know where the ones are that are missing from my class today.
Right.
So,
sorry, that was important to me that we were closer.
That's good, though. That's good, because they're all going to be our awesome AP Calculus students next year. So
that's right. Okay, right. Yes, I am ready. I can flip to sharing my screen and we'll get started.
Okay, sounds great.
Okay, so hopefully you guys are seeing that lovely PowerPoint. I will give you a couple of seconds here. Actually, I won't, because you can do it later. And normally I would give you a few seconds to write that essential question, but I know my thing is blocking it too, but I'm going to leave it there. Anyways, you guys had that ahead of time, so we're going to just jump right in. We are on page 250. Hopefully that is the correct page number. Hopefully someone let Miss Ballard know, type it in the chat if it's not. All right, so we're going to run through these definitions. We are going to look at them. So the word trigonometry, in case you ever wondered what that was, why we have this fabulous big word, it's about triangles. So this is measurement of triangles. So trig is all about stuff with triangles. Then we have angles. This is our rotation of, rotating array. And we're going to see that over here on the right. So the angle is the rotation from the initial side over to the terminal side right there. Then we have initial and terminal side. We have to know what those mean. So initial side, I'm going to actually grab a pen here and write a little bit. The initial side is always the side that we're starting with. And we'll see if my pen is being agreeable today. It's a little bit better. Okay, so that initial side is always where we start measuring from, and the terminal side is where we end. Of course, I said the pen was better, and then it's not. So I might give up on that. We'll see. Okay. All right, so our initial side is going to be always where we start, and then the terminal side is where we end, and that is just horrible, but you can see those right there. So initial is start and terminal is end. All right, so then the vertex of the angle is that end point where the two sides come together. And when we go into the very next one, which is standard position, I really do want my pen, I'm sorry. I was trying to cheat it and it's not agreeing with that. So give me 1 second. I can resync it. Sometimes that fixes it. There we go. Okay, so when we go to standard position, this is very, very important. Moving forward, most, if not all of our angles are going to be on a coordinate plane, so an XY axis, and we consider standard position when the vertex is at 0, 0. So up here, this vertex right here is going to be at 0, 0. The initial side is going to line up with the x-axis. Always, that's going to be our standard. That's why it's called standard position. And we're always going to measure from the initial side going counterclockwise around the coordinate plane. And then the terminal side, that's where we stop measuring. So this is our end or the stop point, and the initial is where we start. Any comments, Ms. Ballard, you want to add before I go on?
No, I do not have any comments.
Okay.
Nor are there any questions in the chat, so we're good.
Yeah, and you guys should already hopefully have these written down. If you didn't, again, go back and write them down later and make sure that you know what those words mean. But initial and terminal side are going to be really important today. Also knowing standard position is vertex is at 0, 0. Initial side copies right over the x-axis. Okay, then we have a positive angle. This would be, as I mentioned a moment ago, we're going to measure, typically our angles are going to be, well, I got a dot there. There we go. Our angles are going to be measured from the x-axis going counterclockwise. So you can see that in your picture, it's going counterclockwise, and my pen is just really being unhappy. Miss Ballard, I don't know what happened. It was perfect the first day, and today and yesterday, it's just not happy.
It is not happy.
No, that's all right. So positive is going to be going counterclockwise, which you guys might remember in geometry when we did rotations. We talked about counterclockwise being the standard direction. So all of that ties in here as well, that that's going to be our preferred direction. But then we have negative is basically if we start always starting at that same initial side or the x-axis, and the negative we just count, or I'm sorry, we measure our angle going backwards, so to speak. So that's negative. Any questions, concerns?
I do not see any.
Awesome. Then the last, I think this is the last part of what I'm doing, is coterminal angles. Coterminal angles are angles that have the same initial and terminal side. So if you look at the figure here, we have alpha and beta, Greek letters from our Greek alphabet.
Oh, you're going to have to sing that again because we didn't get it recorded.
Oh, that's true. Well,
that could be something we look forward to at the end of the lesson.
There you go. All right, so this one up at the top, this is alpha. You can see this is a positive angle measured in the positive direction. And it ends right, whoopsie, right here. And then we have beta. This is the second letter of the Greek alphabet, measured in a negative direction. But you can see both those angles stop on the same line, even though my drawing now has made it difficult to see. They both end at the same location. So they both start at the x-axis, that initial side, and they end at the same place. Those are called coterminal angles because they are together. So they start and stop in the same place. So their measurements are going to be different. You can see angle A, hopefully you can see this is larger. It goes past 180 degrees. I'm sorry, alpha, not A. And angle, the beta angle is a little bit less than 180 degrees. But together, they start and stop in the same location. You can also see in the second picture that you can create coterminal angles by completing a whole circle and coming back. So if you see alpha, this would be, let's say that angle is, I don't know, 40 degrees, even though it's probably more than that. Let's do 50 degrees, for example. And then we look at beta, that's the one with the little swirly here. We start at the x-axis and we go past the terminal side and keep going around and around and around and around. But when we stop, we still stop at that terminal side. Those are considered coterminal angles. The only rule is you start and stop in the same place. So that one, that second angle would have been the whole circle around, which hopefully you remember from geometry is 360 degrees, plus the extra 50 degrees that we went past the circle. And so that looks like 500. I'm sorry. Anyways, put those together and you would get your coterminal angle is 410 degrees. We'll do that more later, but that's kind of a quick look at that. Sorry, it's really bothering me that it looks like 500 degrees or 500 instead of 50 degrees. See, Miss Ballard, what you have to put up with me. I just get so picky.
It's all right. It's all good.
But I'm not boring. Oh, wait, no, I am. Because yesterday.
Oh, no, that's my job is to be boring.
All right. So I believe that is, yep, that's where I jump out.
Right.
So I'm going to stop sharing.
I'm going to present my screen now, and I'm going to do some more definitions with you guys. Okay, so you should be seeing my screen now. It says I'm presenting to everyone. Can you, Miss Rondo, can you see my screen?
I can see your screen. It says it says you're presenting to everyone. But so,
okay.
There we go. Yay.
That's not the right thing.
No,
that's calculus. So I'm getting there. There we are. That's
Yay.
Trig. Okay. So we're going to talk about the measure of an angle, and the measure of an angle is the amount of the rotation that is required to rotate one side called the initial side to the other side called the terminal side. So just like Miss Rondeau was telling us, and I'm sorry, I can't write in red. That's too Hemet high, and what's up with me? So it drives me bananas. Plus, I just hate the color red.
Well, I just hate changing it every time. That's why, that's the only reason.
So if I have that angle there, just like Ms. Rondeau was saying, it could be like she was representing the 40-degree angle. But if I take it and I rotate it around more, then we have that. What did we say? Was it? We said 3. Oh, you did a different angle.
I ended up doing 50. It's okay,
yeah,
though.
I did 40. So mine would be 400 degrees if I wanted to rotate it all around. Typically when I draw something like that, I will put the little arc in there, and I'll put the little swirly arc in there for when it goes around more than once. And we can do this a lot of times. So we can take this and we can go around a whole bunch of times. So an angle is no longer just between 0 and 180. It can go bigger than 180. It can go bigger than 360. It can go bigger than 1,000 if we really wanted it to. Okay, we're not going to see that many, but you just have to understand that that's there. It also can go in the negative direction. There's a directional thing to it, which we'll get to here more in just a few minutes. So this is, we talked yesterday a little bit, and then when you saw Desmos, about radians versus degrees. So there is another measure that we use for angles, and it's called a radian, okay? And it's basically, it's the measure of the central angle that intercepts the arc S, equal in length of the radius of the circle. So basically what they're saying is this radius right here on the thing, if I laid it out, if I took a piece of yarn and I measured that radius and I laid it out on the circle, it would be the length of that arc right there. And that would give us what we consider 1 radian, okay? So, I used to do an activity where we used to kind of trace that out and figure out how many radians that went around a circle. It's about 6 go around a circle. It's a little bit less than 6. It's a little bit less than 6. Okay. You're going to kind of see that a little bit. You might have to, I think I showed one today in the homework where you have to pick whether it's like 1 radian, but that's what it is. The radians are just little radiuses laid out around the circle. A central angle, which you did learn in geometry, is an angle whose vertex is the center of the circle. So this here would be considered a central angle in there, where we have marked theta. All right. Oh, here we're going to see the 6 radians. I can prove it to you here. I totally missed that was coming.
Let me jump in for a quick second, Miss Ballard, too, guys. Keep this little chart handy, because like when you get to your homework, or just sometimes when it asks you to like say what quadrant it's in, this is a really handy representation. Because most of the time when we do radians, we don't do pure whole number radians. We don't usually count them 1, 2, 3, 4. You'll see later. But this is handy. You might want to mark that, draw a little star next to it. Handy to have that reference. Sorry, Miss Ballard.
Yeah, I completely agree. Because there is some times where they just do the whole numbers. It's very rare. What we're going towards is we're going to go to radians that have pi's in them. So a central angle is 1 full revolution counterclockwise corresponds to an arc length of 2 pi r. And hopefully you recognize that 2 pi r is really just the circumference of a circle. That's where that's coming from. But if we go all the way around the entire circle, we know that that measurement is 2 pi. Okay, if I were to write all those radians around there. 2 pi, if you just estimate it, that's 2 times 3.14, which is 2 times 3, which is about 6. So it's a little bit more than 6, which is why there's 6 radians. Okay. Half a revolution around. So half of 2 pi is pi. So half a revolution around is what we would call pi radians. And I know this seems really weird right now. And we're gonna keep morphing it. So just hang with it, okay? And I know today's a lot of us talking at you, not a lot of interacting. Then a quarter of a revolution around. So if I hit right here, okay, would be taking the pi radians and dividing that in half. So take the pi and divide it in half, and you'd have pi over 2 radians. And then a 1/6 of a revolution around, okay, which is going to probably land us, I don't think I have on this one. It's going to land us kind of more in this direction, but I'm basically going to take that pi and I'm going to divide it by 6. So it's going to be pi over 6. All right, and you're going to see that illustrated kind of in the next little picture. So it shows you these are some popular radian measures that we tend to see. You're going to start seeing these values over and over and over again. They're super important for us. And as we move into calculus, you're going to see these over and over and over again. So we've got pi.
Mrs.
pi.
Ballard, go back for a second
Uh-huh.
on your previous slide. You were
Mm-hmm.
doing a sixth of a revolution, not a sixth of pi.
Thank you.
You're welcome, no problem.
A sixth of a revolution is still pi over 6, though, right?
No, pi over
Oh
3.
no, a sixth of a revolution is pi over 3.
Yep.
I messed. Thank
No
you.
worries, not a big deal.
All right, let me fix that. I wasn't doing a sixth of pi. I totally blew that. All right, because I got away from looking at my notes. All right, so
you're fine.
A sixth of a revolution, meaning I've got to divide this. Oh, okay, I see where it's at. So a sixth of a revolution, do we see how we have 1, 2, 3 wedges up there? So that would mean that we're not quite there, but we would be about a third of that area up there. So we're going to call it pi over 3 radians. All right.
You can also, maybe to help them out too, I know I saw it when I was looking at your previous notes where you actually showed them dividing the 2 pi, the whole circle, by 6, if that helps. Okay. I don't know.
Let's try that. So if I'm at half a revolution, I'm taking the 2 pi and I'm dividing by 2, so that gets me pi. If I need a quarter of a revolution, that's probably where I should have gone.
No worries.
I'm doing 2 pi over 4, which reduces 2 pi over 2. And then if I'm doing a sixth of a revolution, we reduce to pi over 3. So that's where it's coming from. All right, I think we're good now. Good thing Miss Rondeau is watching me today.
No worries.
All right, we've got a lot going on. All right, so as we were saying, these are some common angles that we have. We've got pi over 6, pi over 4, pi over 3, pi over 2 pi, and 2 pi. We're going to see other variations of this, but these are the basic 6 that we see. I'll start talking about over 6 and over 4 and over 3 and over 2 world and what goes on in those eventually, because there's commonalities between the angles. So this here is just to help us get started on understanding the quadrants. And you've probably seen the quadrants before, at least probably in your Algebra 1 class. Hopefully your teacher named them for you. We start here at 0 degrees or 0 radians. We're gonna kind of live in both worlds for a while. So it's gonna be 0 degrees or 0 radians at that measure. When I come here, we know from all of our years in math that that's 90 degrees. It's a right angle, right, Andy?
Yeah.
Okay. And he's lurking to tell his joke. So we also know that we just learned that that's pi over 2. Okay. And we always go in this counterclockwise fashion. Over here, we know that that's a straight angle, so it's 180 degrees or pi. And then down here on this bottom, that would be another 90 degrees, would be 270 degrees. And that one happens to be what we call 3 pi over 2. Don't worry about understanding that yet. We'll get there. Just write it down. And then if we finish this revolution, so this angle is not only 0 degrees or 0 radians, it's also 360 degrees or 2 pi. And then we like to name these quadrants so we know what we're talking about. We'll talk a lot in the next couple weeks about which quadrant are things located in, and that's how we're going to help you do your unit circles. We'll say, okay, which quadrant is that in? So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And if you don't remember that you have to go counterclockwise, just know that you label the quadrants like a C for calculus. So it goes in the order of drawing the letter C. All right, I get to do 2 more definitions, which are kind of a little weirdly misplaced, but I'm going to go ahead and do them, and then we'll talk about them here in a few minutes. Some examples in a few minutes. So these should be things that you know. Andy, come here. Do you know what acute and obtuse are? Really? Yeah. I think my second grader weren't you studying acute and obtuse?
Yeah.
Yes. Okay. So you should know what these are, since my second grader knows what they are. Acute angles between 0 and 90, or in our new radian world, between 0 and pi over 2. So something that still falls kind of in the first quadrant. Anything you could draw in that first quadrant would be what we consider acute. Obtuse is anything that's between 0 or 90 and 180, or pi over 2 and pi. So if we're in both quadrants, anything you could draw in here is going to be obtuse. Okay. Any questions or concerns from the chat, Miss Rondeau?
Nope.
Okay, Andy, come here.
Yes.
Okay, we're up for our joke of the day. Since we're about halfway through the lesson here, I'm going to try to get back to here, and I'm going to Stop presenting. All right, Andy boy, tell us that joke.
What happened to math teacher's garden?
What happened to the math teacher's garden? I don't know what happened to the math teacher's garden.
It grew square roots.
It grew square roots. Oh my
That's
goodness.
great.
Our garden has square roots in it. You should go out and check.
All
All
right.
right,
So,
Rondo, you are up because I know this is your favorite part.
yeah, no, this is my favorite part. Miss Ballard knows because I just love it. We're gonna skip through those definitions. Okay, this is my favorite part. All right, so on your notebook page, I think it should be page 251. You should have some circles that look like this. So
You're not presenting yet.
I'm not.
No, you were not.
Meanness. Okay, hold on. I don't know what happened. I clicked. Maybe I didn't. Oh, I didn't confirm. I didn't confirm. Okay, so now do you guys see my screen?
We're good now.
Okay, perfect. So you guys should have circles that look like this. This is my favorite part because I really enjoy, I guess I just enjoy fractions, but I enjoy showing where radians actually come from, that those numbers that we were talking about, pi over 3 and pi over 2, they actually mean something. So here we go. If you will take your first circle and we're going to label it. We're going to practice this a lot. We're going to label that first at the x-axis like Miss Ballard was doing a moment ago. We're going to say we're going to start at 0 degrees. And as we rotate, I'm sorry, I said 0 degrees, which is true, but I want to do it in radians. So it's 0 radians. We're going to rotate. Sorry, my pen is being just a little bit silly. We're going to rotate this way. So as we rotate around and go the whole circle, that whole rotation is 2 pi. So I tend to write my 0 a little bit above and the 2 pi below, just, it doesn't really matter, but they're both at that point on the circle where we've gone all the way around the circle. So 0 and 2 pi. So like we did a moment ago with Miss Ballard, we talked about the different ways we can break up the circle. If I only went halfway, so if I went here and I only went halfway, then I would call that pi, because all the way is 2 pi, halfway is pi. So what I would like you to do also here is on your paper, which mine's going to show up as a line, I want you to trace over and draw your x-axis. I know you already have it, but if you will draw over it, if you have color, that might be better because you're going to see mine are all color-coded to help us see. So that's kind of our first line of reference is the x-axis. We build everything from there. Then I'm going to continue to divide my circle into sections. So still with your color or your pencil, you're going to draw the next line. So what we're going to do then is we take pi and we're going to divide pi, which is 180 degrees. So it's only half of your circle. You're going to take that and you're going to divide it into 4 sections. And you're going to draw all. I'm going to
interrupt for just one second. Their circles apparently on their page only have the x-axis.
Oh, that's okay.
That's okay. You guys, if you want to, you could just lightly sketch your y-axis in there. The y-axis on
don't do it. Don't do it.
Don't do it. Don't do it. Don't do it. Never mind. Don't do it.
It's better if it only has x.
They don't have it. You're going to see why. So just bear with us a few minutes. Okay, guys?
Yeah, no, thank you, Mrs. Ballard. We want to make sure that's clear. Yeah, just if you guys just follow the markings that I end up putting on in color, you'll be okay. Okay. Yeah, so some of them use the y-axis and some do not. So that's why we don't need the y-axis yet. Okay, so we have our x. We're going to draw in. We're going to cut that top section. I'm going to actually maybe help you guys out so you can see. Come on, pen. So much fun dealing with technology. Okay, there. Oh, that's why it's the eraser. The lag is killing me. Okay, well, maybe I won't. But we're looking at only the top part of our circles. But when we draw, you're going to draw it all the way across like this. So I want you to cut pi in half. So you're basically creating that y-axis that you didn't have. So go ahead and do that. So now I cut pi in half in the top half of my circle, I have 2 sections. In the bottom half, I have 2 sections. Okay, so the top pi is cut in half and the bottom pi is cut in half. All right, so because of that, and I do need my pen here. Come on, honey. There we go. Okay, I want to label those angles. Maybe. Oh, dear, dear, dear. My apologies for my pen being a little bit slow. There we go. Okay, so we're gonna label. I actually think it might be the battery, the way that it's acting. Okay, so maybe I'll come back and label them, but if you guys can go ahead and do it, and I will see if I can get some assistance from my family to come bring me a battery. But at the top of the circle, that should be pi over 2, just like you labeled a minute ago, because we took pi and we cut it in half. And then the bottom is 3 pi over 2, because if we count, yeah, I really can't do this without the pen. Give me 2 seconds.
Okay, if you can't get it working, I can always put mine up and you can talk me through it.
Sorry, we're gonna.
I like how you have to use the phone to call.
Yeah. Honey, can you get me a AAA battery, please?
Sure.
Like right now? Thank you. Yes, and that's on our recording too. Isn't that great? We'll see if in the meantime I can get it to go a little bit better.
Can you imagine this awesome piece of stuff that we have now for our children, our grandchildren to watch?
Okay.
Here's the point in history what we had to do.
Yes. So it's like working but not working. All right. So at the top, this one would be pi over 2. And at the bottom, this would be 3 pi over 2. But really, this is all about counting. So if I start at 0 and I was to count, how many pi over 2 angles did I create, or how many sections did I create? The first one. Why don't
you guys put that in the chat? How many sections did Miss Rondeau create in that circle? I don't see anything in the chat yet.
They're all mad about my pen not working.
Apparently.
Thank you. All right, we're going to see if this helps it out.
Nobody's listening.
Yeah, they're done. Oh, it's so much better. It was the battery. Awesome. Okay.
Stephanie says 4. Oh, here it comes. Here it comes. There must be a huge delay today.
There might be.
It's coming. They're saying 4.
4 sections, yes. So
4 sections.
When we're looking at radians, though, most of this is built in terms of pi. I mean, it is the whole circle, but it's really about how many sections we're dividing pi into. And when I talk about that, I'm talking about how many sections do I divide the top half of my circle pi. So if we look at that, the whole circle has 4 sections, but pi has 2. That top half only has 2. So if I go through and count them, I start at 0. Up here, I have 1 pi over 2. I'm just counting, normal counting, 1 pi over 2. Then the next one, I would also consider that 2 pi over 2. And when we reduce that, we get pi. So if you see the counting side of this, I have 1, 2, and what number comes after 2? Is Andy there?
3.
3. The next one is 3 pi over 2. And when we complete the circle, going all the way around, the next number is 4. So we would have 4 pi over 2. When you reduce 4 pi over 2, you're back at 2 pi over 2. I'm sorry, you're back at 2 pi. So this kind of helps us create that numbering system that we're going to see. If I would encourage you to write those equivalent, I don't know why I went to the pen, equivalent fractions, because I feel like they are helpful. You start with 1 and you just keep counting, 2 and then 3 and then 4. All right, so then from there, we're going to add one more section. I said we were going to divide pi into 4 sections. So right now we've only divided pi into 2 sections, even though the whole circle has 4. Now we're going to go one step further. So go ahead with your pen. And you don't need to do this in a different color. I have it in a different color to specifically highlight where we are. You can use the same color. You're going to draw two lines for me, one like that and one like that. So now I have divided my pi, my top half, into 4 sections. So when I go to start labeling these, the first one would be 1 pi over 4, or we just say pi over 4. The second one would be 2 pi over 4, which reduces to 1 pi over 2, or pi over 2. So those are equivalent fractions. Then I keep counting. The next one I have 3 pi over 4. And the last one I have 4 pi over 4. So it's really about counting around the circle, and the pi over 4 tells us how many sections pi was divided into. So then I continue. The next one would be 5 pi over 4. And then we have 6 pi over 4, which happens to reduce to 3 pi over 2, which we already had. And then the next number after 6 is?
7.
7 pi over 4. And then we finish it off with 8 pi over 4, which equals 2 pi. So again, this is all about dividing up your circle, specifically dividing pi into a certain number of pieces. And then which piece are we talking about? The first piece, which is here, the second piece, which takes us to here, the third piece, which is here, and so forth. And when I say which piece are we talking about, remember, we're talking about building angles, and that line that you drew would be your terminal side of your angle. All right, so that's the first circle. Then we're going to switch to the next circle, and we're going to start the same way by drawing our x-axis. And I'm going to erase a little bit just because I want to have room to build this stuff on the next circle. So on the next circle,
we know this is kind of silly to do all this counting, but it's really important that you understand these pieces. That's why we're spending so much time on it today.
It really is. And when we get into some of the examples, you'll hopefully see why we do this, because you can build in radians, you could build pretty much any angle and not know necessarily the exact degree value of it, but you can, yeah, it's very handy, very helpful.
Yes.
Okay, so we're going to start with 0. And once I've hit the half circle, 180 degrees, that would be pi in radians, and then 2 pi. So everything starts with the x-axis, 0, pi, 2 pi. And then we're going to talk about breaking down pi into pieces. So pi, meaning the top half of my circle, this time we're going to divide it into 3 sections. So I'm going to actually ask a question for the chat. If I'm dividing pi into 3 sections, what fraction is that?
So if I'm going to repeat the question, you guys should be putting in the chat. If Miss Rondeau is going to divide pi into 3 sections, what fraction would she end up with? Still waiting. I bet there's a delay today a little bit.
That's okay.
Fallon's saying probably thirds.
Thirds, I like it.
Yep, pi over 3
Pi
from
over
Valerie.
3.
Oh, we got a pi over 3 from Sach. So it's looking pretty good. I think we've got it.
Okay. All right. So yes, we're going to divide it into thirds, 3 sections, which means pi over 3, or pi divided by 3. So if you will add in these lines for me. So I draw it all the way through the circle. So my top pi is divided into 3 sections. Here's the first section, here's the second section, and here's the third section. And then the same for the bottom as well, it has 3 sections. So mine has the y-axis in it, but it's actually not one of my division lines, which is why I was saying don't add the y-axis. It doesn't help us on this particular problem. It is there. So if you at this point want to put kind of a very lightly there, that's fine. But for counting our sections, it's not part of our count. All right, so my first one would be 1 pi over 3, or my first pi over 3 section. The next one would be 2 pi over 3. And then the next one would be 3 pi over 3, which of course reduces to pi. Then I continue counting 4 pi over 3, 5 pi over 3, and then I end at 6 pi over 3, which again reduces to 2 pi. Do we have questions or concerns before I go on? How are we doing, Mrs. Ballard?
I haven't seen anything come up in the chat yet. So if you guys do have a question, put it in the chat, and I can relay that message, or I can answer it in the chat too.
Awesome. Okay, so we're going to take what we just did. That's all we're going to do on that circle is just the pi over 3, because these, again, are our standard angles. These are the ones that are most important to us, pi over 4, pi over 3. Actually, we didn't talk about this yet, but I do want to pause here. Sorry, one more quick thing. If pi is the same as 180 degrees, those are equivalent values. And I just took pi and divided it into 3 sections. How many degrees is each one of those sections?
Interesting question. So put it in the chat. So if that pi is 180 degrees, how many degrees is each one of the 3 sections? I'm seeing a lot of 60s coming up.
That's right. And I'm going to just keep moving us through because this does take a while and I want us to get through all of our stuff. So yes, it is 60 degrees. I would ask you guys to actually make a note that pi over 3 equals 60 degrees, maybe draw a box around it. That's going to be important for us to know. If I take 180 degrees and divide it into 3 sections, it is 60. So I want to actually go back to my previous one where we were drawing pi over 4 angles, where I divided my pi into 4 pieces. And I want to ask, what does that equal in degrees? So if I take pi, or 180, and divide it into 4 sections, what does that equal? Go ahead and answer that in the chat.
So can you repeat the question for me? Oh,
yes. If I take pi and divide it into 4 pieces, what is the equivalent degrees? So basically 180 degrees divided into 4 pieces. How many degrees is each one of my sections?
gotcha. I'm seeing a lot of 45s.
45 is correct. And again, I would encourage you to jot that down. Pi over 4 in radians is the same as a 45-degree angle. All right, so let's go to our last circle. Once again, we're going to start with that same first line, 0, pi, and 2 pi. And this time we're going to divide our circle into, we're going to start by dividing it into pi over 3 sections. So 3 sections again, just like we did a moment ago. Okay, and we already have these lovelies marked out on our previous one, so I'm just going to copy them. The first one's pi over 3, then I have 2 pi over 3. This one was 3 pi over 3. Down here at the bottom, I'm going to sneak it right here, is 4 pi over 3, and then this one was 5 pi over 3 and 6 pi over 3. So that's the work we already did. You don't need to necessarily catch all those up. You can do it later because you do have the reference right there. Then we're going to go a step further and we're going to divide all of those sections in half. So basically we're going to be taking pi and dividing it into 6 sections. So right now it's 3. So I'm going to take each section and divide it in half. So you should have 6 sections on the top of your circle and 6 sections on the bottom. I'll give you a second to do that. All right, so since I'm taking pi and dividing it into 6 sections, this first section I would call 1 pi over 6, or pi over 6. The next one would be 2 pi over 6, because I'm just counting 1 pi over 6, 2 pi over 6, and notice the equivalent fractions. The next one would be 3 pi over 6. If you look back at our first circle, we had that same value at the top of pi over 2. So that still is the same. It's just now I wrote it in pi over 6 units. All right, so then after 3 would be 4 pi over 6. And then we have 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. We just keep counting around. The bottom, 9 pi over 6, which again, we already saw this bottom y-axis marker labeled as 3 pi over 2. So those should be equivalent fractions if I did my counting correctly. Then after 9 pi over 6 would be 10 pi over 6. This last one here is 11 pi over 6, and then we're back at the circle 12 pi over 6. So when we do these different radian measures, so now we've created all of them, we always write our angles in simplest form. So if I go back up to like this one I wrote it as 4 pi over 6. It is a pi over 6 division. However, when we list this angle, we're always going to call it 2 pi over 3 because that's the reduced version. So that is important to know, but this is how it is created. Any other comments, Ms. Ballard, before I jump into examples?
I think you're good to go.
All right, so let's see how we actually use that process to help us out on the questions, some of the questions we're going to see. All right, so this says determine which quadrant each angle lines. That's weird. We need to fix that typo.
Lies.
Yeah. The angle measure is given in radians. So you can cheat and go back to your little circles and figure out where 5 pi over 4 is, or I'm going to have us practice drawing it. So we're always going to start with the x-axis. Here's 0, pi, let's see, pi, come on, pi, and 2 pi. This right here tells me to take pi and divide it into 4 sections. So in the top here, I'm going to divide it in half and in half again. So I have 4 roughly equal sections. Don't make fun of my non-equal sections. I tried. Okay. What we're looking for, though, is what quadrant it's in. So if I were to, I only did the x-axis, I want to remind us that this division in half would be our y-axis. So there's y and there's x. And I divided it into 4 sections. I need to count to the 5th section. Right now, I only have 4 sections, so I got to divide the bottom as well into 4 sections. Then I'm going to start at my x-axis, my initial side, and I'm going to count 1, 2, 3, 4, 5. Which quadrant am I in? Go ahead and type your answer in the chat.
Ooh, put your answer in the chat. Which quadrant did we land in? I'm seeing a lot of 3s. I think
3.
they got it.
Awesome. So 1, 2, 3. That is quadrant 3. And I'm going to kind of rush through these a little bit because I, again, want to make sure we get through everything. So I'm going to do that same process again for part B. So I have 0, pi, and 2 pi. And again, because we do want the quadrants, I'm going to put a little dashed line to help us see that's going to be our y-axis. But when I divide pi into 3 pieces, that's not one of my division lines. So I'm going to divide pi into 3 pieces. So there's my 3 pieces. And I, again, need to count to the 5th one. So I have to also divide the bottom. You can do it all at once. It's totally fine. I usually do it in pieces at first, at least. So I want the 5th one. I have pi over 3 sections. I took pi, divided into 3, the bottom divided into 3, and now I count. 1, 2, 3, 4, 5. Which quadrant am I in? And
All
for
right,
the interest
in the chat.
type it in the chat. Okay, we will. One more time.
Okay, we're doing fine. We're going to probably cut a little at the end.
Okay, so this is going to be quadrant 4. Thank you guys if you typed it in. I'm just kind of.
Yep, they did. They got it.
Awesome. All right, so this next one, oh no. In our problem so far, we never divided pi into 12 pieces. We also have a negative sign. The world's just coming to an end. No, not really. Okay, so we're going to do our same start. 0, pi, 2 pi. I want to divide pi into 12 pieces. So I'm literally going to go through and divide pi into 12 pieces. So there's cutting it in half, cut that in half. I'm just going to make up roughly. So now I have 4 pieces. I need 1, 2, 3, 1, 2, 3. So this is not going to be perfect, and that's okay. We're looking for what quadrant it's in. So I want to figure out what quadrant. And hopefully I got 12 pieces there. I'm just going to highlight for us, this is the y-axis to give us our quadrants. And I am looking for the 7th piece, but I have a negative. So I have to actually do the bottom as well because a negative means I have to go backwards. So I'm going to cut up the bottom as well. Do my best here. I don't know if I did that even close to right. Let's see. I have not the right number.
Yeah, you need one more.
Not even close. I was not paying attention. I'm sorry. I mean, I am, but I'm not. Okay. Now is that 12? Yes. Okay.
Yeah.
Don't mind that it looks awful, but it's really okay. I'm going to actually change colors so we can see a little bit better. All right. So the negative means I still start at X always. That's my initial side. I'm going to count backwards and I'm counting to 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Which quadrant am I in?
Hey, really quick.
Yeah.
They aren't even waiting for me to say put it in the chat. They're saying quadrant 3. They're getting really good at this.
Yes, so it is quadrant 3. So again, when it's negative, we just go backwards from the x-axis, going down to begin with. And then again, the steps are you take pi, figure out what it's divided into, draw your picture, and then count. For D, looking at -3, this is where I'm going to tell you to reference. Go back to the part, oh dear heavens, that was not the fastest way. Sorry, I was looking for, nope, that's not what I want either. The slide where you guys had, there we go, this one. It was, I'm sorry, what was part D? Is it -4 or -3?
I'm sorry, I moved off of that. Part 4 is D is -3.
-3. Okay, so if I look at this in the positive direction, this is why I said this picture is going to be really helpful. There's 1, there's 2, there's 3. I almost make it to the x-axis going in the positive direction. So if I recreate that negatively, I would go 1-ish, 2-ish, and 3. And I end right before the x-axis in the negative direction. So what quadrant would that be in?
So what quadrant did we land in there? Put it in the chat real quick. A little bit. Don't go back yet, Miss Rondo.
Okay, sorry.
Got one more. It's 4.25. They're saying quadrant 3. They're doing a good job. Everybody write down quadrant 3.
It is. I'm going to put it on my answer in the next one too.
Yeah.
But that is why I mentioned you guys really want to make sure to keep that handy.
You probably want to stay there to do 4.25.
Oh, I see what you're saying. Yes.
Yep.
Okay.
Yeah.
So this was quadrant 3.
And I want to make one real quick comment there. I know a lot of you were typing in regular integer numbers. When we write quadrants, the proper notation is to use that Roman numeral. So
yes.
It isn't, notation hasn't been as big of a deal, but as we go into next year, it's going to be huge. So.
Okay, so now I'm going to actually erase my work here because the next one is positive 4.25, Mrs. Ballard?
Correct.
Okay, so I'm going to follow around. Here's 1, here's 2, here's 3, here's 4, and then 0.25 is about a fourth. If I look at this, if I only go a fourth more, am I going to still be in quadrant 3 or am I jumping to quadrant 4? What seems reasonable?
Go ahead and put it in the chat. What seems reasonable? Quadrant 3 or quadrant 4? Oh, Fallon. Excellent job. Fallon got the Roman numerals.
Nice.
Oh, Ariana did too. Capitals though, Ariana. They're capitalized, okay? So I'm seeing a lot of 3s.
Okay, I'm going to jump back. Yes, it would be 3. Actually, let me go back for a quick second because if I roughly estimate kind of a fourth would put me about here. A fourth of the distance, I'm still in quadrant 3. Okay, and the point on these questions where they're asking what quadrant is not to give an exact picture necessarily, is we want to know, do you understand where it is? And so that gives us that understanding of where it is. Okay, so we're going to jump to the next one. This one's sketchy angle in standard position. So this is a lot of... I think
we're going to just end with sketching today, Ms. Rondo.
Okay, no problem. Yeah, because we are... I'm sorry, Mrs. Ballard. I take a long time.
No, hey, no worries. I'm good to go.
You get to start tomorrow again.
Right, I get to start. That's okay. I'm good with that.
Okay. All right, so we're going to always start when we're sketching an angle in standard position. We always want the x-axis first, 0, pi, and 2 pi. And hopefully you've noticed every single time I start with that. Then I'm going to build. I want to divide pi into 6 pieces. And so you can build it in the top and then the bottom. This time I'm going to be a little bit more to hurry us along and do the whole circle at once. So I'm going to divide the top into 6 pieces, which means I'm going to cut it in half. That's my y-axis. And then 3 sections. No, I can't do it. I'm sorry. I'm so well trained to do it in. Sorry, I normally do it top and bottom. So that's what I'm so well trained to do. There we go. 6 sections in the top and 6 sections in the bottom. And granted, these hopefully are fairly accurate to division, but we are sketching it, so it doesn't have to be perfect. So I'm at pi over 6, and I want to count to the 7th piece. So I'm going to start here, and I am going to draw this arc, little circular thing I'm going to draw is part of your standard position. 1, 2, 3, 4, 5, 6, 7. I like to draw the arrow, but you don't have to draw the arrow. Just the arc is included in your angle being drawn in standard position, and that is 7 pi over 6. Mrs. Ballard, any comments or things that you would do differently, or I don't know?
Nope, looks good. I sometimes will draw like dashed lines until my final one, but that's just preference.
Preference. Okay. I just want to make sure that we're preparing them with proper expectations. So.
Nope, we're good. And they're gonna do this one. These ones in the assignment are a little bit more multiple choicey. So.
Okay. All right, so we're going to jump into B. Again, we set up 0, pi, 2 pi. This time I'm dividing pi into 3 sections. So I'm going to do 1, 2, 3. And notice I didn't even do the y-axis on this one. Honestly, I don't typically include it. I might put it in as a dashed line, actually, which is maybe different than Miss Ballard, because we know the y-axis exists. I'm worried about the angles, getting the angle drawn correctly. So pi over 3, I want to count to the second one. So again, I'm going to go 1, 2, and I like to put the arrow. The arrow is not necessarily part of it. Make sure you do have the arc, though. That shows which angle you're talking about, and this is 2 pi over 3. All right. Part C, this time we're going to do a negative angle, but our beginning process is the same. 0, pi, 2 pi. I'm dividing pi into 3 sections. So one more time, 1, 2, 3, 1, 2, 3. And then I'm going to count to 4, but I'm going to go in the negative direction. So I'm going to start at 0. That's always my initial side. And I'm going to count backwards. 1, 2, 3, 4. And that would give me negative 4 pi over 3. All right, for my last one, 2, a whole number 2. This is where the system kind of breaks down and where I would encourage you to go back to that picture, honestly. We know that a whole circle is a little bit more than 6. And so if you break that up, that means half a circle is a little bit more than 3. So if I want 2, I believe 2 is somewhere about right here. So your 1 is over here and your 2 is over there, something like that. But for reference, I would definitely look back at this picture. Ooh, I did pretty good.
Nice job.
Yeah. So 2 is roughly right there. Where did I go? This one? Oh, back one. Sorry. Okay. So there you go. That that finishes that part. We still have about 5 minutes.
I think we're going to probably let it stop there and not get into anything else. They've done enough. I adjusted the assignment, so you've done enough for the assignment.
Okay, perfect. Then I'm going to put that away, come back to you guys, and stop sharing my screen. All right. Any other? Oh, I'm like, there's 57 comments. Oh no, that's all the comments that everyone is typing in. Good job, guys. Any other questions, concerns?
All right, so we're going to keep going with this lesson tomorrow. This stuff in particular, it's setting us up to do what we call the unit circle, which is a super, super big deal, important for
Calc.
For calculus. Andrea, I'm not sure what you're saying in the comments. So let me know what that means. It's too long to be a phone number. There's no decimals, so I can't be pi, so I'm not really quite sure. Or has a younger sibling got a hold of your machine like my children do? So,
Maybe.
all right. So we're going to end it there. You can check out, my link will be in Power School. I know Miss Rondeau's will be in Power School, and whatchamacallit, and Google Classroom. We're going to have a WebAssign. It'll be a WebAssign up there today. Remember, we're going to give you enrichment points for this. I know some of you are still working on grades. Some of you are just doing it to learn, which is great. We love seeing that. So keep up the good work, and we will see you again tomorrow at 10 a.m.
Bye,
right.
guys.
Bye. I hit that button.